Welcome back. In the previous video, we briefly introduced pattern recognition using a visual example by navigating a character through a staircase sequence. We described this recurring sequence of up and right using pseudocode, which is just a description in English of what we want an algorithm to do. In this section, we are going to learn more about how we use repetition in designing computer programs, starting out with how we can use flowcharts as a tool for thinking about and designing repetition, and then moving on to our first examples of using repetition in processing. When creating any kind of program, whether it be an app, a website, or digital art, what we are trying to create might be too complex and difficult to code without designing it first. Programmers often use diagrams or flowcharts to help map out the design of their code, and to help them break the problem they are solving down into smaller, more easy to solve parts. Designs not only help programmers work out what they have to do, but they can also be useful for helping others understand how the code works, and to help work out why code might not be working as expected. Flowcharts are one common tool to assist with designing programs, as they help us to analyze processes. When we create a flowchart, it allows you to break any process down into individual events. For example, if we were to develop a flowchart for climbing stairs, it might look something like this. First, we indicate that we are starting a flowchart, which indicates the start of a sequence of instructions. Then we follow by our sequence of stepping up and stepping right instructions. If we have not yet reached the end of the stairs, then we want to keep going and therefore repeat the up and right actions. If we have reached the end of the stairs, we want to stop. This flowchart is simple but contains everything we need to know in order to understand repetition in programming. You need to define the sequence of instructions that are to be repeated, i.e. the pattern that we have identified. You need to define anything that needs to happen when you start, and you also need to define a Boolean expression which tells you whether you need to keep repeating the instructions or not. If you remember our earlier discussion of Boolean expressions, these expressions, when evaluated, will give you either a true or a false result. Let's have a look at another flowchart, in this case a flowchart which describes the action of filling a bathtub with water. In this flowchart, we start by executing the instructions for turning on the tap and then seeing how much water is in the bath. The instruction we want to repeat is that of checking the water level in the bath. If it is not high enough for the bath, then we leave the water running and continue to check it. If it is high enough, we proceed to turn the tap off. We can embody this in our algorithm by including the Boolean expression to check whether the bath is full enough. If the answer is false, we keep running the water. If the answer is true, we stop. This process of breaking our problem down into smaller instructions is a computational thinking process we refer to as decomposition. Decomposing a problem into smaller subcomponents helps us to figure out exactly what needs to happen and how at each stage. In breaking down each individual event, we display the flow from start to endpoint and the logical relationships between each event. Flowcharting helps us to clarify what needs to happen or what is happening, and helps our understanding of the process and how we can improve it. Flowcharting in computer science involves the use of a particular set of symbols. These symbols are used to provide a consistent approach to flowcharting designs, and makes it easier for others to read our flowchart designs and understand the key processes. In this course, we will use some of these symbols to help draw our flowcharts and work out our algorithms. The first symbol we will use is the arrow, which tells us the direction of logical flow through our flowchart. The second symbol is the oval, which is used to represent the start or end state of our algorithm. Next is the rectangle, which represents a process. And finally is the diamond, which represents where we make a choice. As you can see, repetition is not explicitly represented as a symbol. It comes from the inclusion of a choice in our algorithm, where we can either choose to move forward to new instructions, or we can choose to repeat instructions we've already seen. Now let's see how we can use flowcharts to design an algorithm for a processing program. We want to draw an image that uses repetition.